is now they're just going to give you polynomial functions that you just have to, I would say this is factor completely that we did already in like R5, which means look for GCF. You might have to do factor by grouping. Make sure that you factor everything that you can, and then you just set it all equal to 0 and get your answers. But again, it says find the real solutions, which does not mean to just cross out everything that's negative. It means make sure that you don't give me an imaginary number. You can't take the square root of an imaginary number. That's the big lesson here today. So for number 1 here, what do you think would be a good first step here to solve this equation? Yeah, there's an x in all of those. You don't really have to write this sentence down. That's just me, like, summarizing what we're doing. But if I pull an x out of this, I'd be left with x squared plus x minus 20. And then I can factor this, right? I can make some more parentheses. And what multiplies to give me 20, that subtracts to give me positive 1. Positive 5, negative 4. And then you're just going to set each one of those factors equal to 0. If you had like a 2 out here and not an x, you can't set that equal to 0. It's not an x. But I can set x equal to 0. That's just x equals 0. That's going to be x equals negative 5. And x equals positive 4. I'm not going to cross out that negative 5 just because it's negative, right? Like, negative numbers are still okay. It's just if it made the whole problem not work. I'm not even going to check my answers on this because there's nothing crazy going on. You got to check your answers when you have radicals and fractional things like that. But on a problem like this, like, there's not going to be extraneous solutions. I mean, you can check them if you want, but they should all work. And you get the right answers. That's not so bad, right? There's only one or two. No, it's mostly pretty good. Like, there's 1 or 2 at the end that are a little bit harder. But the rest of them are pretty, like, factor by grouping is the other thing on today's homework, which we do all the time anyway. So, what about this one? Some people would say, let's divide by x squared. But when you divide by x, you lose some answers. So you never want to divide by x. If you see x's on both sides, I think a good first step is move them to the same side, like subtract one of those over. So I think a good first step is subtract that 3x squared over. Okay, so don't divide by x. Not a good thing. Because then if that was written, you probably would know what to do while reading x. Yeah, we can factor out an x squared on this one. And I'd be left with 4x minus 3. And then just like the last one, can I just set both of those equal to 0? And I get x squared equals 0. Which I'm just going to take the square root of both sides. And I can't have a negative 0, so it's just still 0, right? You just get one answer. X equals 0. And this one, 4x minus 3 equals 0. So I get 4x equals 3, or x equals 3/4. 2 answers. You okay with that? What about this one? You can't take a GCF out of that because they don't all have anything in common, right? But yeah, factor by grouping we're going to throw in there because we can group together those first 2 terms, we can group together the last 2 terms, and we can factor by grouping, and it should work out that we can then set those equal to 0 and solve them. So of these 2, I could factor out an x squared, and I'd be left with x minus 3. Remember, you want these to be the same, so there's a 4 in both of these, but we need the signs to switch. So I'm going to factor out a negative 4. So that would make that x minus 3. And then remember, factor by grouping, we're going to take the part that's the same and pull it out front. So I'm going to pull out that x minus 3, and then what's left is x squared minus 4. And then you can set each one of those equal to 0 and solve them. This one's really easy. You get x equals 3. This one I would add 4 over, so I'm going to get x squared equals 4. Take the square root, and I would get plus or minus 2. So we actually get 3 answers on that one. We get 3, positive 2, and negative 2. I always forget that. You could factor that also if it helps. You could factor in x minus 2, x plus 2, and then you would bring it to plus or minus, right? So factoring would work there too. You could factor more. That's most of your homework. Then I threw in a couple that I was that's what I was doing on that first one that she asked me about, was the whole 1/2 thing. Because look at this next problem. Ready? This is where it gets a little crazy. Oh, how this problem. There's one, I think there's one of these, yeah. That was a lot of right? Yeah. There's so many x's, I'm getting them. So x times x squared minus 3x to the 1/3 plus 2 times x squared minus 3x to the 4/3 equals 0. That'd be kind of awful there. The idea is, you see how those parentheses have the same stuff in them, but they have different powers? Yeah. We could pull out the smaller exponent, and that's what I was talking about earlier, thinking about like when you factor something out, you're subtracting the exponents. So what if I factored out an x squared minus 3x to the 1/3? And again, I want to do one of these with you. I have one on your homework, and I'm sure we'll talk about it tomorrow. But I want you to at least like think about this. If you take that out, let's think about what would be left. And I'm going to put a big bracket here for what's left, just because there's going to kind of be a big mess left. But the first part here, that's pretty easy. If I take out this, it's gone, and I'm just left with x. Everyone agree with me on that? Yeah. That's the easy part. Plus, this 2 is still here. Do you agree with that? Now, we want to think about those exponents. Remember when we factor something out, it's like you subtract this exponent from what you factored out. So if I take this 4/3 and I subtract 1/3, what's left up there? 3/3, which is just to the first power. You with me on that? 4/3 minus 1/3 is 3/3, which is really just like saying that's to the first power, so I don't have to have a weird exponent on it anymore. 4/3 minus 1/3. Just give me 1 left. And although I still have parentheses here, can I kind of work this out now?
Why did that one come out? Why did the x squared minus 3x come out too?
Say that again.
Why? Because you have it out there at the beginning.
Right.
X squared. Why did it come out from behind the 2?
Because we took the 1/3 out, but there's still, like, we could actually think about this as, like, there's 4/3 there. So if we take one of them out, there's still 3/3 left, and 3/3 is just to the first power.
Yeah.
Does that make sense? Just like if you had an x cubed and you took x squared out of it, you have 1x left over. So that's kind of the weird math part there. And now we could actually work this out. This is still equal to 0. This is just x squared minus 3x to the 1/3. And I could set that one thing equal to 0. X squared minus 3x to the 1/3 equal to 0, because it's my one factor. And this is my other factor. I can set all that equal to 0, and I'm going to distribute at the same time. X plus 2x squared minus 6x, because I'm just distributing my 2. And I'm going to set that equal to 0 too. And now I have a little bit more work to do, right? I'm going to solve each one of those. Which one, what will we do to solve that side over there? What will we do to get rid of that 1/3 now? Cube both sides. Really nice, because what's 0 cubed? 0, so I have x squared minus 3x equals 0. Then could I factor an x out of that? And get x minus 3. So from this part, I get x equals 0 and x equals 3. But then I also got to clean this side up over here. And again, I think it's going to be kind of similar. I'm going to have 2x squared 1x minus 6x is minus 5x. And could I also factor an x out of that? And I'd be left with 2x minus 5. And I get again that x equals 0. So since you get the same answer twice, I mean, you can include it, but it's just one of those double roots. So if you only wrote it once, that's okay. But we also get an answer of add 5, divide by 2. So you really get x equals 3, x equals 0, x equals 5 halves. There's one of these on your homework today, and I just want you to try to think about what would happen if you factor that out. Yes. Mm-hmm. Right here. Let me look at your paper. Okay, I work. Most of your homework today isn't so bad. One like this. Okay, so let me go and give you your assignment, and then I will look at them on paper. This is 1-4, day 3, 74 through 88 even, and then 103 is a question about, like, they did this question, they got the wrong answer, what they do wrong, but it's a square root problem. But all of them but 88 are like the easier thing, where you're just trying to set it equal to 0, maybe factor by group, maybe factor out GCF. You shouldn't need to check your answers today. They should all work.
Say that.
I know, I say that.